Hello, and thank you for joining our webinar, Sustainable Solutions, a look at reduced emissions for vehicle interiors. I'm Lisa Arrigo with SA International, your moderator for this 30-minute program. Our two speakers are experts in sustainability and engineering who will discuss lightweight renewable solutions with an emphasis on emissions reduction in the cabin and during the manufacturing process. They are Tonja Sutton, the Global Strategic Marketing Manager of Interior, Exterior, and Underhood Applications at Dow Automotive Systems, and Dr. Esther Quintana, the company's EMEA Market Manager. During this webinar, you may download a PDF of the speaker's PowerPoint slides by clicking the link on the left-hand side of your screen under Event Resources. You may also send questions to our speakers by using the Ask a Question box. Tonja and Esther have agreed to reply to all questions they receive. An archive of this webinar will be available on the SAE website at www.sae.org/webcast immediately following today's presentation. If you have difficulty seeing or hearing any part of the program, please refresh your system by using the F5 key. This will correct most problems. Or click the question mark on the screen to access the Help menu for additional advice. And now, let's begin our discussion by welcoming our first speaker, Tonja Sutton, the Global Strategic Marketing Manager for Interior, Exterior, and Underhood Portfolios, and the Sustainability Marketing Liaison for Dow Automotive. Tonja joined Dow in 1979 as a chemist and has held positions in technical service and development supporting many polymer technologies at the customer interface. In 2005, she transitioned from technical to commercial positions for different business units within Dow Automotive. She is a two-time recipient of the prestigious Pinnacle Award and has over 25 years of experience in the automotive industry. Hello, Tonja. Welcome to our webcast.
Hello, Lisa, and thank you. As mentioned in the introduction, we would like to spend some time reviewing how our customers, the automotive manufacturers, both OEMs and tiers, are under increased pressure to improve sustainability, fuel efficiency, and emissions. We are finding that technologies that enable solutions to address these challenges have become a priority for our customers. Today we will discuss macro trends and their impact on light vehicles, changes in emissions targets and requirements, as well as lightweight renewable solutions with an emphasis on emissions reductions. And we will highlight a technology for reduced cabin emissions, which Esther will review later in our presentation. So to look at some of the macro trends that could affect the automotive industry moving forward, by 2030, the world's population will reach 8.3 billion people. This will require 50% more food, 45% more energy, and 30% more water. These changing world demographics will definitely have an impact on the needs of our transportation industry as well. Much of this growth will occur in emerging markets, where air quality is a priority. So emerging markets have the potential to explode the impact and the need for lightweight vehicles, fuel efficiency, and reduced emissions. And technologies that have the ability to address these needs have the potential to impact the lives of millions of new consumers in our industry. By the year 2050, global transport for people and goods will more than double. This means initially an increase in the number of vehicles in the world, which will ultimately lead to increasing emphasis and the need for reduced emissions. One source estimates that for a sustainable scenario in 2050 for our planet, the allowable amount of CO2 per day that our planet could support per person per day will be 4,000 grams. To put this into perspective, if you commute to work, for example, in your car 15 miles or 20 kilometers on a round trip per day, you have just used your daily allotment of CO2. So ultimately, in the long term, this will drive large changes in how we transport both people and goods. The future of transportation is also dependent on technologies and materials that are enabled by innovative chemistry that can help us address the need for these reduced emissions, improve fuel efficiency, while at the same time maintaining safety and meeting safety requirements. Today, greenhouse gas emissions from transportation account for about 30% of our total U.S. greenhouse gas emissions, and governments globally are calling for more fuel-efficient vehicles. Already we have seen that technologies which are enabled by science are making vehicles lighter, helping to improve fuel efficiency while reducing emissions, both exhaust and cabin emissions. And we will discuss some of these technologies that are enabled by science later in our presentation. So if we look at the macro drivers and trends in the world, things like CO2 regulations, improvements that are called for in fuel efficiency, globalization, performance expectations such that we deliver vehicles that our consumers will want to purchase, sustainable solutions, all while meeting the safety requirements and regulations. These will drive key trends in the automotive industry, such as lightweight vehicles, downsizing of powertrains, and this is enabled by lighter weight vehicles' body structures as well as lighter weight vehicles overall. Electrification, both hybrid and fully electric vehicles, global specifications from our customers, reduced cabin emissions, as well as life cycle analysis that's being completed on vehicles. And we're seeing now the coming of automated, connected, and autonomous vehicles. So let's look at some of the material solutions that can address these needs of the world and our industry. Structural adhesives, which enable lightweight and dissimilar substrate joining, lightweight composites that now can be manufactured at rates required for high-volume vehicle platforms that are used in our industry, as well as lower density foams for the interior, all help reduce weight and can also be based on renewable technology. Autocatalytic polyols reduce amine emissions in the cabin and have the ability to enhance processing as well. So what we find are that these macro trends drive innovation in our industry, and that partnering with our key customers to understand and implement these is very key. Some additional facts: nearly every car on the road today is too heavy to exist in 20 years. So how much weight do our vehicles need to shed? The industry projects a 20% reduction of total weight by 2020, while the National Research Council has estimated that in 2025, the average vehicle will be more than 400 pounds lighter than it was in 2008. And the U.S. Department of Energy's long-term goal is to reduce vehicle weight by 50%. So if we think about vehicle mass, some very large, impactful changes happening in our industry. In terms of fuel efficiency standards, evolving targets that have been adopted or are being considered are shown for global regions in the graph at the left. The U.S. has set the 54.5 mile per gallon equivalent by the year 2025. At the same time, some of the other regions are focusing on lower CO2 emission targets, which correlate to lighter vehicles as well. So what we find in the industry is that the call for mass and emissions reductions, plus changes in legislation, drive innovation in our industry. And this is very important for our customers to avoid penalties that they would have to pay if, for example, they could not meet the fuel efficiency and emissions targets. In the U.S., the CAFE and greenhouse gas midterm review will happen in 2017 through 2018, with final recommendations happening in the year 2018. And this will help determine whether the long-term targets that we see here will remain as they are projected. There are also changing trends impacting the vehicle interior as well, such as continuing need for comfort inside the cabin while meeting passenger safety requirements, all while maintaining the quality, again, that delivers a vehicle that consumers would want to purchase, and sustainable solutions that will help meet these needs and trends. These drive the need for volatile organic component reduction, as well as the reduction of materials that can contribute to fogging in the vehicle, as well as odor. So we see the drive for improvements continuing for cabin air on the interior of vehicles. Since polyurethane materials, including foams, can be a very large component in the vehicle interior, this points to a need for polyurethane foams which have decreased total volatile organic compounds, amines, and odor. So the automotive community is taking a proactive stance on reducing emissions by setting aggressive targets, particularly in Europe, with considerations currently happening in China. And the global specifications that we discussed earlier in our presentation are also going to drive the move for improvements coming in North America as well. So looking at some of the interior trends for emissions, we find that there are many tests that have been developed for automotive interiors. Today, the industry is self-policing, and our OEMs interpret and set their own individual specification requirements for emissions, VOCs, and odor and their related testing standards. To date, we have found that the European OEMs have been driving the emissions requirements. However, some countries like China have not regulated yet with any test methods and emission level requirements, but they are considering future regulations at this time. So looking at some of the examples of current VOCs, fogging, and odor emissions tests, we see this table, which is not meant to be a comprehensive list, but it does highlight the differences in test methods which are used by the various OEMs for interior emissions requirements. And it also shows that there is a self-directed process being used to set these requirements today. As you look at the table, and you can see the differences in the test methods and the limits that are being set. An area of recent focus has been aldehyde emissions in the interior. This table again shows examples of emissions tests for aldehyde components, again highlighting the differences we see in the various test methods being used by the OEMs. In China, the government is considering legislation for aldehyde emissions, but they have not yet finalized the test method to be used or the requirement levels. As a supplier to the automotive industry, it's very important that we work with our customers to address improvements in materials, processing, as well as new formation in the interior, all of which can contribute to cabin emission levels. So to leave you with a summary of some of the sustainable solutions for reducing weight and emissions in light vehicles, this slide shows a portfolio of product technologies that can assist our customers in meeting today's vehicle challenges for lightweighting and reduced emissions. Betamate and Betaforce, for example, are structural adhesives which are based on epoxy and polyurethane chemistry. And they facilitate the joining of lightweight, dissimilar substrates such as steel, advanced high-strength steel, aluminum, field plastics, and composites. Vorforce products are composite solutions which can help meet the cycle time requirements for high production vehicle volumes. Structural beta foam is an example of a reinforcement technology which can be used in the vehicle structure and can help reduce weight over some of the other reinforcement technologies. Specflex Renew and Betafoam Renew are polyurethane systems that contain renewable content and can also deliver lower density foam systems for vehicle interiors and NVH improvement in body structure cavities. Specflex Active is an autocatalytic additive polyol for polyurethane foam systems which can help reduce cabin emissions and odor, and Esther will explain in further detail in the next portion of our presentation. And finally, we wanted to let you know that a sustainable solutions calculator has been developed which can help estimate the typical savings in weight, CO2 emissions, and fuel efficiency improvement by using one of these technologies or combinations of them. So if you're interested, please feel free to follow up with us regarding this and following the webcast. So now I will turn the presentation back to Lisa, who will introduce Esther. Esther is going to discuss a technology for reduced cabin emissions and odor, which can help increase cabin comfort while at the same time reducing the weight of interior components. Thank you. Lisa?
Tonja, thank you for that excellent presentation. Yes, our next speaker is Dr. Esther Quintana, the Marketing Manager for Interior, Exterior, and Underhood Portfolios with Dow Automotive Systems for the EMEA region. Esther joined Dow as part of the Polyurethanes Research and Development Team in 2007 as a process chemist engineer. Since then, she has held positions in R&D and technical service and development, supporting seating application technologies. In 2014, Esther moved from the technical to the commercial function and her current role. She received a PhD in physical organic chemistry in 2005. Esther, thank you for being with us today.
Thank you, Lisa. I'm going to be focused in explaining polyurethane foam solutions and what the automotive has been recently put into the market. For this one, I would like to start explaining where polyurethane foams are used in the interior of a vehicle. We use polyurethanes in seating solutions like front cushions, backrest, headrest, and armrest. Over there is very important lightweighting, low emissions, and the high comfort. We use as well polyurethanes in noise, vibration, and harness applications, like carpets, dust mats, or under the hood. There is as well very important the lightweight, the low emission, flame retardancy requirements, mainly for the under the hood and the engine cover, and absolutely the acoustics. And the last, we also use in some other interior applications as instrument panels, headliners, steering wheels. As well over there is very important the low emissions, properties and safety, and absolutely the acoustics. So it is very clear that low emission is a key issue that we need to solve. Then, as you could hear before, another very important point to address is the lightweight. Because of this, toluene diisocyanate technology in seating is a very good compromise to achieve possible density reductions and as well very good properties. If we are able to solve emissions and as well the aging. In fact, the TDI market is predicted to grow at 4.8% from this 2015 till 2023. And it's as well because TDI, it is being used to produce seating parts for the rear, but as well for the backrest in the front. How do we develop the different polyurethane solutions? We need to take care of the global OEM requirements, and over there is the emissions, together with the physical mechanical properties, without forgetting the right density. But as well considering that the tiers need to be able to implement these solutions. This is why the process is very important. So together with the demo time, the curing, and as well the right harness to be able to produce the part that the OEM is requiring. Speflex Active polyol additive family has been developed in order to reduce or even eliminate the catalyst producing polyurethane foams. This will depend on the tier process conditions and as well on the formulation know-how. The foams produced are unique and they are completely different, having the advantage of process for the different tiers. In the table, you really can see the characteristics of Speflex Active as the hydroxyl number, viscosity, and water, having typical polyol characteristics together with the standard safety labeling. Speflex Active additive polyols are working catalyzing the blowing reaction from the beginning and continuing with the gelling reaction later on. Basically, Sperflex active can be introduced together with different other polyols, with surfactant and water, and then being able to react with TDI to start the blowing, later on the gelling reaction to produce stable PU foams. The main advantages for an OEM of using these new breakthrough autocatalytic additive polyols are to have finally fully compliant foams in terms of physical mechanical properties and aging, low emission, including amines content, together with the odor. In addition, the density advantage of the possibility of using TDI as the isocyanate. In the different pictures, you can see polyurethane seating foams using this new family of autocatalytic polyols in a backrest. Then, let's explain more the advantages of this autocatalytic additive polyol, starting from the properties. Over here, we have used TDI formulations, and starting from a reference with a not low emission foam, we can compare with the next best alternative, then using low emission, and then different formulations containing this new autocatalytic additive polyol. In all of these three different last formulations, we have used zero catalyst and an amount around 12 parts of the autocatalytic additive polyol. What we can see is that we are able to meet the physical and mechanical properties, including the aging, as you can see in the humid aging compression sets and as well the wet compression sets. And we are able to eliminate the amine emissions for a more sustainable solution, as Tonja mentioned before. If we move to the process and the density advantages, we also have compared with a reference not low emission, then comparing with a low emission next best alternative, and then exactly in the same way with formulations containing the new autocatalytic additive polyol. What you can see is that in the three last formulations, we are having a broader density range cover with a very good process stability. We also can produce very open foams, very differentiated in TDI technology, having the possibility and the unique capability of overpacking with using only one formula. In fact, there is the potential to save even 20% of density to achieve lighter weight seating solutions. Then, to finish with the emissions and the odor. In this case, we have compared a reference, a not low emission solution, with the worst case scenario of a formulation containing the new additive polyol. Then what we can see is a significant decrease of the total VOCs, as well the fog. No amines have been detected, together with decrease in acetaldehyde and a dramatic decrease in odor. So we can affirm that we are able to meet the emissions and the odor requirements. To summarize, we can say that this new autocatalytic additive polyol is a new solution for low-emission polyurethane foams. It can allow the tiers to meet the most difficult OEM requirements for VOCs and other specifications, including non-detectable amines. In addition, we also can have lightweight advantages of using TDI as the isocyanate, having excellent physical mechanical properties, including humid aging and different aging tests. We can add significant process latitude improvements, producing very open foams with TDI, easy to crush, with excellent flow mold filling, critical for parts as the backrest, including extreme overpacking tolerances using only one formulation. And this solution is very easy to use and implement. It is a liquid, easy to blend on the polyol side and use as an additive, and it's a chemical handling easy with the properties described before. With this one, I finish, Lisa, and I'm ready for the questions.
Thank you, Esther.
Thank you
very much for that wonderful presentation. It's time now for our question and answer session. Remember, you may send questions to our speakers by using the Ask a Question box. Tonja and Esther have agreed to reply to all questions they receive. And Esther, this first question is for you. Can SpecFlex Active be used for applications other than seeding?
Thanks, Lisa, for the question. Yes, so this new autocatalytic additive polyol can react with different isocyanates, and it can be used in different applications. All will depend on the know-how from the peers and on their process conditions. This new autocatalytic polyol is in fact the magic to be used depending on what are the issues that we want to solve. It can help in process conditions, it can help to reduce emissions and odor, or to help you to meet the difficult physical mechanical properties, including aging.
Thanks, Esther. Tonja, you have the next question. How do these trends affect the vehicle design cycle and supplier or OEM or tier interaction? Tonja?
Thank you, Lisa. If we look at the lightweighting and emissions trends that we discussed in the webinar, and the fact that the automotive OEMs are considering sustainability throughout the vehicle life cycle, it's important that suppliers and automakers, our customers, work together as early in the design process as possible. And why is this important? It's important so that some of these sustainable solutions that we've discussed have the chance to be implemented in the manufacturing process. Or, for example, if an OEM has set goals for a certain amount of weight reduction for a vehicle platform, we as a supplier can work with our customers to project how much weight savings could be gained or emissions reduced if they used one or combinations of the technologies that we reviewed, the structural adhesives, lower weight foams, composites, etc. So the impact of these solutions early in the design phase can be considered, and strategies together we can develop to be able to implement these in manufacturing.
Very good. Thank you, Tonja. You also have the next question. What about circular economy considerations? Do any of these technologies help?
Thanks, Lisa. That's a great question and one that we're focusing on as we move forward for our industry. A circular economy is an approach that focuses on retaining more of the value of the material, the energy and labor inputs that go into our products, including reuse, recycle, waste reuse, energy recovery, and others. Our company has a goal, in fact, to, by 2025, implement several projects that can be supported for this business and other businesses as well. And some examples in automotive of where we are working with our customers on projects that include a circular economy are reduction of landfill waste, including improvements in packaging, and also the use of post-industrial automotive materials, which are included in new product formulations that go back into the automotive applications as new materials. And as Esther mentioned, products like SpecFlex Active, for example, allow interior materials to have a longer use and life. And because they have better performance when they're recycled, they have better property retention for reuse applications because of their improved aging performance.
Very good. Thank you, Tonja. And with that, we're at the end of our webinar. I want to thank both our speakers for today's presentation. I also want to thank our audience for being with us. In a few moments, a survey will pop up on the screen. Please tell us what you thought of our webinar by answering its 3 short questions. This webinar will be archived for the next 12 months at www.sae.org/webcast. You may continue to submit questions through the Ask a Question box or download a PDF of the slides under Event Resources. I'm Lisa Arrigo with SA International. Thanks for joining us.